Good afternoon. Afternoon, I'm right at the back. Good afternoon. Woo, there we go. Last session of the day. There we go. Thank you. Thank you so much for coming along. I know these MMS days, they're very long. You go to a lot of sessions during the day and labs and other stuff, and you're obviously partying. So it's a long day, but I do appreciate you staying right to the end and coming along to the session. Now, this session is focused on a follow-up from part one, which we covered on Monday. And in this session, we'll look at specifically the competitive advantages of Hyper-V versus vSphere 5.1. Now, a lot of the comparisons, a lot of the stuff we'll talk about is very, very useful information that you can use in your environments, whether you're a partner working with customers, whether you're a customer evaluating your own environment yourself. So there's going to be a lot of comparison tables, a lot of useful information of yes, no, we do this way, VMware do this another way. So you're going to come away from this session with a lot of useful guidance around comparing the two offerings. And as I said, this session is very much focused on the hypervisor layer, so the virtualization layer, which I'm sure many of you have or are virtualizing. So it's going to be a useful comparison following on from the previous session that we looked at on Monday, focusing on the private cloud stuff. Now, my name is Matt McSpirit. I'm one of our technical product managers focused in Windows Server and System Center. And I've got a background of virtualization and virtualization management, both on Microsoft and on VMware as well. So, before we get into the comparison, it's important to understand just where Hyper-V has come from. So back in June 2008, we introduced Hyper-V for the first time. But I tell a lie, actually earlier that year, so January, February of 2008, when Windows Server actually was released, there was a beta of Hyper-V in the product at that time that you could download, you could add on, and install and enable. But in June of that year, Hyper-V RTM'd and brought with it a number of key features: high availability, the ability to move virtual machines around, but with a slight pause to the virtual machine with things like quick migration. And it gave us some good scale and performance levels. But then fast forward a little bit to October of that year, and we released another product called Hyper-V Server. Now, a lot of people think that actually the only way to get hold of Hyper-V is as part of Windows Server. So I go and buy Windows Server, I install, and I enable the Hyper-V role. But actually, there's a free edition of Hyper-V that's got all the same Hyper-V goodness, but it's completely free to download for everybody. The key differences, or the few differences, are it doesn't have a GUI, so it's command line based effectively, but now has PowerShell, and we'll touch on that a bit later on as well. And it didn't have some of the key features and capabilities that were within Hyper-V and Windows Server. So there's a little bit of disparity in this release. It also doesn't give any of the free guest operating systems that you get when you license Windows Server as a platform, as a host. So if you just wanted to virtualize Linux or you were doing virtual desktops, Hyper-V Server was great because all of the licensing for that sort of stuff was away from the data center, for instance. But as I said, there was not parity between Hyper-V Server and Windows Server Hyper-V at that time. But then fast forward a year, and Windows Server 2008 R2 and Hyper-V Server 2008 R2 came to market simultaneously, and it's at that point that Hyper-V Server was brought in with parity in terms of features and capability and scale with the full GUI edition of Windows Server and Hyper-V. So you had now a choice, not based on features and functionality, just based on deployment type and what you were most comfortable with. And as you can see on the slide, we introduced a number of key features that, with all respect to the competition, some of these features that were already in place with their technologies, like live migration, was already in the VMware suite of tools at that point. We brought it to Hyper-V, we made it a free feature, so it was accessible to a lot of organizations, both small and large. We then started to introduce features that would enhance how we integrate with storage. So prior to 2008 R2, the best practice and recommended guidance for deploying virtual machines with Hyper-V was one LUN per VM, which didn't necessarily make it easy for storage admins, and it wouldn't have made the most scalable solution and best use of that storage that you had. But cluster shared volumes solved that and allowed us to place multiple VMs on individual LUNs, gave us huge LUN sizes, and allowed you to be a lot more flexible with your usage of storage. There were countless performance and scalability improvements that brought Hyper-V on the radar for a lot of organizations. And then in 2011, early in 2011, the Service Pack was released, which for both Hyper-V Server and Windows Server Hyper-V, that brought two new features. So at the time, service packs were pretty much focused on patches, fixes, and stuff like that to optimize. But this brought two specific features for Hyper-V. One, to increase density with dynamic memory, and we'll touch a bit more on that a bit later on. And the second, incredibly useful for VDI environments, particularly where users need a very rich graphical user experience with remote effects. Now, if you've not seen remote effects, at the time, it harnessed physical graphics cards within the physical hosts and will pass them through to virtual machines, of which multiple virtual machines could share individual graphics cards, and would see a rich user experience as part of that. They were both introduced as part of the service pack. And that brings us to 2012. That brings us up to date. And for the session and the comparison that we're going to do, we're going to focus on 4 key areas. The first is around scale. Running my big mission-critical workloads. What can I get out of Hyper-V? How far can I push it? How big are the hosts that I can run? What about the virtual machines? How big? And how do they compare and contrast with VMware? Is this applicable to both Hyper-V Server and Windows Server 2012 Hyper-V? Absolutely. So everything we go through will apply to both. We'll look at security and multi-tenancy, some of the improvements we've made in the networking stack around the extensible switch, and how we can provide organizations who want to simplify and manage their network more effectively and plug in third-party tools. We'll talk about how that's defined and delivered within Hyper-V. We'll look at some of the migration capabilities, because these were some of the coolest innovations and additions within Windows Server 2012 and Hyper-V. The flexibility we provide now to move stuff around, move virtual machines anywhere with no ties is phenomenal, and allows admins to have complete flexibility within their infrastructure. And we'll also touch and explain a little bit about network virtualization. And finally, we'll wrap up with making stuff resilient. How can we deliver continuous services? So yes, we can run at scale and we can run a ton of virtual machines on hosts, but if a host goes down, what happens? How can we provide an extra level of resiliency, both locally and geographically? And we'll touch on some of the key comparisons there as well. So when we come to scale, if we think about where Hyper-V was in 2008 R2 and we compare to 2012, the jump in just one release is staggering. The jump from supporting on the host side, just 64 logical processors in the host, to 320. Somebody in Microsoft somewhere must have a host with 320 logical procs because they've tested it. I'm yet to find where this server is located, and I would like to borrow and probably not return, but it's a phenomenally scaled piece of hardware. And why do we test to that scale? Because we know organizations, maybe not today, maybe not tomorrow, but in the future, are going to be running these huge systems to consolidate incredibly aggressively. And Hyper-V as a platform is going to enable you to take advantage of that hardware without restriction. It's from both the compute, so logical processors, physical memory, and large number of virtual machines on there, so virtual CPUs per host, 2,000, and 1,000 virtual machines per host. That's a huge jump. But if we think about some of the key metrics around the virtual machines themselves, I can create VMs on Hyper-V Server, that free edition, or Windows Server 2012 Hyper-V, and give each VM up to 64 virtual procs with no restriction. 64 virtual procs, no specific licensing required. So I could use that free edition of Hyper-V and still create massive virtual machines. Huge processing capability and big memory support, so up to 1 terabyte per virtual machine. So they're pretty scalable and significant numbers that allow you to virtualize those big mission-critical workloads. When we look at innovation inside the guest operating system, NUMA is becoming more and more important to us as we scale out on these huge multi-processor, multi-core systems with large amounts of memory. And the way we now pass through the NUMA topologies through to virtual machines to allow those virtual machines to take advantage of NUMA is very important. Because if you're virtualizing workloads like SQL Server, which is a NUMA-aware application, or if you're virtualizing the Windows Web Server in 2012, which is a NUMA-aware workload, if you will, or platform, they can take advantage of what Hyper-V is passing through in this guest NUMA example. So again, we're doing our best to ensure that we're delivering the highest levels of performance for key virtualized workloads. And then we think about scale out. We think about scaling out our infrastructure across a wide number of these big physical hosts. And Hyper-V, again, with Hyper-V Server, or Windows Server 2012 and Hyper-V, support up to 64 physical nodes in an individual cluster. That's huge. But when we touch on the migration capabilities later on, you'll realize that the cluster is no longer a boundary of migration, whereas it used to be in 2008 R2. You would create your cluster, and I could live migrate VMs within that boundary. But now, with the innovation we've built into 2012, live migrations can go pretty much anywhere. So the cluster is essentially a boundary of resiliency versus a boundary of moving stuff around flexibly. But we support up to 64 physical nodes and up to 8,000 VMs, so hugely scalable. And we're starting to see now a couple of customers starting to roll this out at that scale for their specific needs. And they're choosing Hyper-V because they couldn't do it on the other platform. When we start to look and compare, on this left-hand column here with Hyper-V, this is Hyper-V Server or Windows Server 2012 Hyper-V. So there's no difference there, whichever you prefer to choose and download and deploy. But we'll compare with the free vSphere Hypervisor. So that one you can just download off the web. You can get it for free, you can register, you can get your key or eval key off VMware, and you're good to use that for however long you want. But it doesn't include any of the vCenter management capabilities. If you want that, you go to vSphere and you attach the vCenter server to manage that at scale. And we can see that Hyper-V, from both a host perspective, offering considerably more scale to take advantage of those big systems. However, 160 logical procs support for VMware is by far and away still more than enough for a lot of organizations. So the fact that, yes, Hyper-V does support 320, and there are going to be some big systems out there that will offer that, 160 is still incredibly scalable. But offering, when we start to drill down and look at the virtual machine specifics, you'll see that VMware, with some of their additions, so Enterprise Plus, Enterprise, and as we drop down the stack, reduce the number of virtual procs that you have available to your virtual machines. So for instance, the free vSphere Hypervisor gives me 8 virtual procs per VM, which is fine, plenty for most applications. But when you go to Enterprise Plus and you pay that little bit more money, then you're starting to be able to utilize the 64 virtual procs per VM. But with Hyper-V, it's in there across the board. You want to create VMs with 2, go ahead. You want to use 64, go ahead. It's completely flexible from that licensing perspective. When we think about memory, again, big virtual machines supported both on the VMware side and the Microsoft side. So a terabyte of RAM on the Hyper-V and a terabyte of RAM on vSphere per VM. And all of these platforms also support that guest NUMA, which means you running your key workloads and applications that are NUMA aware, you're going to see great performance enhancements there as well. And then finally, that scale out. That vSphere Hypervisor, that free download, which some organizations we find are running in branches or remote sites and managing it on a very standalone, isolated basis, one on one on one. But it doesn't have any resiliency. There's no clustering. You have to have a vSphere edition, whether it's a SMB-focused edition, like an Essentials SKU, or whether it's one of the higher-end editions, like Standard or Enterprise Plus, whichever you choose. But the key thing here is Hyper-V is leading the way in that scale out across those clusters, with the biggest cluster support out there for our virtualization platform. So hugely scalable. And like I say, we're starting to see now organizations choosing Hyper-V for those kind of scale numbers to run their big mission-critical workloads. And as Brad called out in the keynote, it's these kind of numbers on these big hosts with these big virtual machines that are allowing us to scale and run these massive workloads. And we've performance tested a number of these workloads. So there's a performance test that's been delivered by Enterprise Strategy Group, one of the partners we work with around our lab testing. And they delivered a test that focused on the scale up of SQL Server and the performance of a 64 virtual proc SQL Server. And they saw huge scalability in performance, but equally when they tested against a comparable physical server, there was only a 6% difference in performance. So we're seeing very, very close performance across physical and virtual. So you're not sacrificing much to go into the virtualized environment with Hyper-V. But in Hyper-V in 2012, and I'm sure you've been to many sessions on this week and perhaps at TechEd last year as well, the number of key capabilities that we're introducing into the platform now to do more cool stuff is phenomenal. And there's areas such as storage, networking, compute, that we're innovating and adding more capability to the platform so you can take advantage. Think about virtual fiber channel. How many people in the audience, by show of hands, have fiber channel storage? Okay, that's a significant number, an investment you've made for your storage infrastructure that wouldn't have been a cheap purchase, I'm sure. It's an incredibly expensive component of the infrastructure. And we want to help you harness that and get the most out of it. So including technologies like virtual fiber channel, where I can now attach a VM straight through to the fiber channel storage, so I can mask and zone my LUNs appropriately working with my storage admin and pass them through to our virtual machine in an intelligent way that doesn't need to expose those LUNs to the host. Because if we want to expose a LUN specifically to a VM to store our databases or our mailboxes or whatever it may be, then we can do that through this virtual fiber channel adapter. And it also gives us some cool stuff around guest clustering, which we'll talk about more later on. So we've got a lot of different flexible options now as more organizations are starting to look at clustering on top of clustering. When we think about industry changes, we're starting to see more and more organizations adopt these new 4K disks, which offer increased performance, alignment, reliability. And Hyper-V, in its new virtual hard disk format, the VHDX file format, has been designed and built to align with that, to ensure that if you do have those 4K disks within your environment and you want to run Hyper-V virtual machines on there, you can do it. So we'll take advantage with the optimal alignment to ensure the performance is optimized. But here's one that Brad called out in the keynote as well, the virtual hard disks. Hyper-V in 2008 R2, just like VMware in its current release, supported virtual disks of up to 2 terabytes. Okay? 2 terabytes was the maximum. Now, I can attach a lot of virtual disks to a Hyper-V virtual machine, well over 250, that would allow me to scale out my storage for that particular virtual machine. But in 2012, with the new VHDX file format, we've just blown that away. 32 times the size of the previous release and 32 times that of what VMware are offering, allowing you to consolidate massive amounts of data into single virtual disks, meaning it's easier to administer, more efficient, and if you did want to scale that out on a particular VM, you could attach enough virtual disks to a single VM that would account for around about 16 petabytes of storage. That's huge to one VM. But these virtual hard disks, not only are they massive, but they're also optimally aligned. Like I said, aligning with the 4K disks. But if you want to run them on non-4K disks, that's fine. They'll run perfectly on there as well. Now, the nice thing as well, if you are thinking about a migration strategy from a previous version of Hyper-V to Windows Server 2012, we can convert VHDs to VHDX files. We can even convert them back the other way if you needed to do that. And Hyper-V in 2012 supports running VHDs and VHDX files side by side. There's no problem there. When we think about some of the other storage capabilities, ESXi on the VMware side can be installed to a USB within the server chassis. You can do the same thing, or our OEM partners can do the same thing with Hyper-V Server. So that's something we'll support with the OEMs to help you if you do want to run a diskless machine or a diskless server. You're going to be able to do that with Hyper-V Server. It's smaller disk footprint, less services running, so that will fit on that USB disk. But there'll be certain requirements of the USB disk that will impose. But Windows Server 2012 and Hyper-V, we don't support that on the USB disk. Okay, so that's something important to be aware of. But going back to those investments, going back to that storage investment that you've made, Fibre Channel was a good example, iSCSI, yeah, that's fine as well, that equally will work as well. We want to help you, again, get more out of those investments, help you extract the best value and the best performance. And that's where ODX comes in. Offloaded data transfer helps admins, organizations, customers, partners to offload storage-related tasks, such as creating a new virtual disk. That's a storage-intensive task, typically, and might take a long time if you're doing that on a single standalone host that's not using SAN. But if you've got a storage array that's intelligent, it's got key enterprise features, capabilities that you've grown to need within your environment, we can hook into that and ensure that we can drive higher levels of performance for certain storage tasks. So, as an example, I'm creating a new virtual machine with a 100 gigabyte virtual disk. If I'm doing a fixed-size virtual disk with regular Hyper-V, and I'm not using ODX, that's going to take a few minutes to complete, zeroing out all of the different blocks within that particular virtual disk. But with ODX, I can tell the SAN to do it, and the SAN will do it in rapid speed, and without burdening the host with extra need and process and compute that it's needed to perform this task. So you're seeing great performance, and it's reducing the burden on the host. Now, does my SAN support ODX? That's the question for you to ask your storage vendor. I know in our environment, we had to update the firmware on a number of our arrays to ensure that we could utilize this functionality. So something to be aware of. And finally, Spaces. Spaces is a solution that allows you to effectively virtualize storage. And as we saw in the keynote, we can effectively take locally attached, direct attached storage, just a bunch of disks that are attached to a standalone host, and we can effectively carve them into a pool and then divide them into spaces. And these spaces are virtual disks that we present to Hyper-V hosts, to applications, whatever it may be. And spaces helps us simplify our storage by just harnessing just a bunch of disks attached to a host or multiple hosts and presenting through these spaces which are resilient. And we're doing this all with just commodity storage. And combine that with some of the other Windows Server features around storage, like deduplications in the box in Windows Server 2012, SMB3 for accessing these storage spaces over a network, SMB Direct, SMB multi-channel. All of these different things are contributing to Windows Server being a phenomenally clever and high-performance storage array just using commodity hardware. And storage spaces and Hyper-V go hand in hand if you do want to run your VMs in that environment. And when we start to do the comparison and start to see where things line up, VMware have had for a good long time virtual fiber channel. So you've been able to pass things through to the virtual machine. And in the same way now with Hyper-V, you can deliver that. So if you want to take advantage of higher levels of performance, passing the LUN straight through to the VM, you're good to go on all three platforms, or all three versions in this case. But if you also want to take advantage of it for guest clustering purposes, again, you've got that option as well. And we'll cover that in a bit more detail later on. One thing I do find very, very useful in the Hyper-V side, though, and this is within Windows Server as well as Hyper-V Server, if I'm attaching my Hyper-V host to my storage, I'm not going to do it with just one connection. I'm going to have multiple paths to that storage, whether it's iSCSI, whether it's fiber channel, whatever it may be. So I'm going to want to use MPIO to help me give me a high level of resiliency, throughput, and performance. With Microsoft, we provide a framework in the box that you can use. So you turn on MPIO, it's a Windows Server feature, you tick the box, next, finish, and you're good to go. A little bit of configuration that you can tweak as well. But we also provide, it's not only a feature, but it's a framework for partners like NetApp and EMC and Dell and HP and all of the other storage vendors to plug into. And there's no specific license consideration about this. So no matter which version of Windows Server and Hyper-V you want to use, you can go out to the storage vendor's website, pull down their DSM, their device-specific module, install on that host, and you're good to go. Because that storage vendor knowledge that you've just pulled down and installed helps you to optimally configure MPIO how they would intend. So it's helping you out, but there's no specific license requirement for Hyper-V. With VMware, however, that free vSphere hypervisor, you can't take advantage of that. If I want to use the equivalent third-party optimizations in my VMware environment, I'm going to need a slightly higher SKU. So I'm looking at the Enterprise and Enterprise Plus edition specifically here. We touched on the disk support and size. Hyper-V's leading the way there. And it may not be commonplace today. There may not be many organizations out there that need a 64 terabyte virtual disk. You know, would I maybe use a pass-through disk instead? An RDM, a raw device map in the VMware world? Well, actually, VHDX files are so close to native performance now that the inflexibility associated with the pass-through disk makes them just not as usable and as efficient and effective as these larger virtual hard disks that we can now create. So I would strongly encourage you to think, maybe we shouldn't go pass-through disk, maybe we should look at these larger virtual disks instead. When we think about if you do want to use pass-through disks, massive support for those disks if you do want to do it. But like I say, you'll lose some of the flexibility you gain with using the virtual disks themselves. With VMware, they've had for a while that ability to offload to the SAN with the vSphere or vStorage API for array integration. So VAAI enables vSphere admins, of which I'm sure there are many in the room, to offload those kind of storage-intensive tasks to the SAN. And like we said, ODX provides that capability for Hyper-V now as well. But with Hyper-V, it's in all the editions. It's in the free Hyper-V server, and it's in that Windows Server 2012 Hyper-V SKU. But with VMware, it's only in those higher editions. Okay, and you can see in the notes there, it's only in Enterprise and Enterprise Plus, of which I'm sure many of you have as well. We touched on boot from USB, and VMware has a lot of flexibility there. So, you know, fair play. Not only can they boot from USB, they can boot from SD as well. So they've got a lot of flexibility. With Hyper-V, if it's Hyper-V server specifically, with the OEM, then you can do it. But Windows Server with Hyper-V, no. You've not got that option for deploying to USB. You can deploy from USB, i.e. I can put the media, the installation media on a USB stick and boot and install to a spinning disk or a SSD, but I can't do it myself into the USB stick itself. And then we'll touch finally on pooling. And storage spaces is an incredibly exciting area that you're going to see evolve and improve as we go forward as well, that allows you to run your virtualized workloads on top of effectively virtualized storage. But the key thing to have in your mind when you're thinking about, is this the right thing for me? When you're thinking about storage spaces, you've got a physical host, maybe it's got local disks inside that host, and you're presenting them through as a pool, and then you're carving them into spaces using the Windows Server GUIs. However, what if you want to make that resilient? How does that work? Well, I could have a shared JBOD array at the back end, just a simple JBOD that's attached to multiple hosts at the same time with the appropriate RAID cards in each of those hosts that's going to allow me to do that. And I can present that through to a Windows Server or multiple Windows Server hosts and create storage spaces that are resilient. Multiple hosts accessing that shared JBOD array. VMware do things slightly different in this place, and they actually offer a capability that can transform local storage into shared storage called the VSA, the vSphere Storage Appliance. And that's an appliance that runs on each of your hosts and effectively transforms local disk and mirrors it across different hosts, so it presents a couple of data stores through to your hosts that are effectively shared. It's almost like building a SAN from no SAN, just from local disk. They're contrasting technologies. They're not aiming to solve the same problem. Okay, so with storage spaces, you do still need some form of back-end storage. But they're offering you different capabilities, different flexibilities to run your virtual workloads on top. So we're both doing clever stuff with storage now in 2012 and in vSphere 5.1. And I know as VMware go forward, they're working on different elements of their storage stack, things like vSANs and the work they're doing with the distributed storage. You know, it's an exciting area for customers and partners and vendors to keep appreciating what's going on in this space. When we think about resources, we want to help you get the most bang from your buck. You're not going to buy a huge server and run just one VM on there. Maybe it's a massive VM, in which case maybe you will, just for flexibility. But for the most part, you're looking to achieve a level of density that gives you a good return on investment. And with Hyper-V and SP1 of 2008 R2, we introduced dynamic memory, which allows organizations to consolidate more aggressively without sacrificing performance. So we're doing some clever stuff around managing the memory we give and we take from virtual machines to help you get the most out of that physical host. Now, in 2012, we've added the ability to be a little bit more granular. So now you can specify as an admin, I would like a startup memory for the virtual machine. I'd like a minimum and a maximum. Because the startup memory, if you think about some of your machines that you have in your environment, when you start them up, they're busy. They're trying to get started, they're starting services, they're kicking the database into action, and then maybe it calms down after 20 minutes, half an hour. So having the startup memory perhaps a little bit higher to let it get started, and then allowing it to drop to a lower minimum is an efficient use of the memory. Now, when Hyper-V detects that the VM's busy and needs a little bit more grunt, a little bit more horsepower, it'll allow that, it'll provide that through dynamic memory, adding memory to the virtual machine as quickly as it can to help it scale, and taking it away when it's finished. Now, that's one of the key memory management techniques for Hyper-V. Now, there is another called smart paging, where if you're in a situation where there just isn't enough memory left on the host, or you're perhaps in a failover situation, so loads of VMs are piling onto a host from other hosts that have failed, and you think, we haven't got enough memory, but we need to get these VMs started. Smart paging will take advantage of a local disk, of which it doesn't have to be SSD, but that may be preferable. We'll take advantage of that local disk to act as memory to effectively get those VMs started. But it's not designed as a get-out-of-jail-free card. It's more designed as a temporary measure that will be used temporarily to help you get those VMs started, whilst dynamic memory starts to grab memory where it can from different VMs that perhaps aren't as busy or in needing it as much. But VMware have a number of memory management techniques, which is very interesting. They have a ballooning technology, which is similar to dynamic memory, at least on paper. They're the most comparable of all the memory management techniques. And VMware also do some interesting stuff around swapping to disk host cache and cool stuff there to help, again, increase your density and reduce the impact of lots of VMs all needing memory at the same time. But one that's up for debate is this transparent page sharing, which Hyper-V plainly just does not have. We do not share memory pages across the VM, so you can't effectively dedupe memory. And VMware does provide that capability. In fact, many of you may be using it in your environments. But as we move forward on modern hardware, we're seeing large page tables enabled by default, and that makes it a lot more difficult for transparent page sharing to deduplicate memory pages. Because the memory pages are no longer 4K, they're 2 megabytes. And so finding memory pages in memory, in the physical memory, that are identical at the 2 meg size is a lot more difficult. So TPS doesn't necessarily have as much of a big impact initially as it would have done if you were running non-large page tables and running legacy operating systems like XP, for instance. However, when the host is under extreme memory pressure, the ESXi host in particular I'm talking about here, then it will start to break down those 2 meg pages into 4K, at which point it can deduplicate those. So TPS still can have an impact, but it's only going to really start to kick in when the hosts are under quite heavy memory pressure, at which case the resources are already limited, and there's going to need to be some resources available to handle the deduplication and the breaking down of the pages. So just something to be aware of. I want to be upfront. You know, Hyper-V doesn't have that capability, but we're confident that we're confident that the level of density that we can provide with Hyper-V is on par, if not better, than what we can deliver with a vSphere infrastructure. We're confident of that. But as more and more organizations are embracing cloud computing, where the network is available, we want to ensure that we can help IT admins, like yourselves, we want to help you understand how you can start to measure resources within the environment and provide information back to your consumers of your IT infrastructure. So for instance, I might want to tell marketing that your 5 VMs for your last campaign are using X amount of resource, CPU, memory, disk, network, and I might want to tell HR that their 2 servers are just consuming far too much and we need to start doing something about that. But to gather that knowledge and that metrics, we need a resource metering capability. And that's within Hyper-V now in the box. So you can run some simple PowerShell scripts that extract that information about the virtual machines and present it back in a format that's easily consumable and can be consumed in other systems as well. So System Center is a good example of a system that will take these metrics and present chargeback reports, for instance. However, there's nothing stopping you either A, building your own front end and dashboard, consuming the resource metering output, or looking at some of the third-party solutions out there for chargeback as well. The nice thing about resource metering is that I can shift virtual machines around the infrastructure, as we'll learn later, and the tracking and the history goes with it. So it helps me to keep a track and understand that even if I move stuff between clusters and in and out of clusters, between standalone hosts and wherever I want to move these VMs to, the metering is still going to be there. So I can still capture that metrics at a later time. It's not going to get reset. Now, something that was a big request from customers around managing resources was specifically focused on ensuring we can give a quality level of service that's consistent. If I'm coming to you as the IT manager and saying, you know what, I'd like to run our new campaign, we need a couple of virtual machines, but I need this level of service because this is mission critical to us. Can you guarantee that? And with quality of service within Hyper-V in 2012, we can give that. We can give a minimum and maximum bandwidth to virtual machines to allow you to say, you know what, if things do get busy on the network for this VM, you're always going to get a guaranteed 100 meg. Or if we think this VM is going to be really noisy, we'll put a cap on you and we'll say, you know what, you can only consume 500 meg or whatever it may be on that network side. And these can be explicit, so I can give it a number, or I can give it a weight. So I can say, you know what, this is a higher priority VM than the other 2, so we'll weight it 70, 20, 10. And that way, this 70-weighted VM is always going to get its more of a fair share of its resources under contention. Now, what I've outlined there is QoS from a network perspective. Now, I know VMware has technologies within their stack for storage as well. It's referred to as I/O control in the VMware environment. Network I/O control and storage I/O control. Network I/O control works in a similar manner. They're subtly different, but they're delivering the same end goal. But there's no storage I/O control equivalent in Hyper-V. So again, being upfront and blunt and honest, that's where we are in today. Okay? But the final one, and something I'm seeing more and more now, is the conversations around how I can manage my fabric more effectively. Hyper-V has been engineered to take advantage of this, and this is data center bridging. What we're seeing more and more in organizations is instead of people buying 2-socket servers with 10 NICs, because that's the kind of thing you traditionally do for VMware environments. I need a vMotion network, I need a HA, maybe a fault-tolerant, a management network, so I need lots of NICs, all with resiliency. We're approaching things differently. Because with Hyper-V, you can still do that. Go ahead, populate a host with as many NICs as you want for virtual machine traffic, for live migration, for cluster shared volumes, and all that cool stuff. But actually, what we're starting to see now is that I'd like to buy a server with just 2 10-gig NICs. That's my approach now. But VMware's telling me, Microsoft's telling me that I need a network for live migration. I need a network for cluster shared volumes. I need a network for virtual machine traffic. How can I have all these networks and just 2 NICs? Well, with the converged capabilities within Windows Server 2012, we can aggregate those 2 NICs and create virtual NICs for the host. So even though you've only got 2 physical NICs that you can plug cables into, 10 gigs, you've got loads of bandwidth, and you've teamed them so they're resilient. Now we're carving and slicing those NICs, of which you've effectively got 20 gig of bandwidth. We're carving them and slicing them and presenting those networks that those individual systems need, live migration and virtual machines and so on. So you can be very clever about managing this effectively in software. And it means you can reduce the number of ports you need, reduce the number of switches potentially, and start to save money. And that's a key design goal for Hyper-V. It's helping you do that. And it's incredibly straightforward to do. And when we look at VMware, as we talked about in a little bit more detail, we talked about memory. I'll make no bones about it. VMware's got some great memory management techniques, but dynamic memory, we're confident, is offering customers that ability to consolidate aggressively with confidence and gain that good level of performance as well. And we're always looking to evolve and innovate, hence the inclusion of the smart paging, hence the inclusion of the startup memory. It's a little thing that helps an administrator just tweak a little bit more naturally. And one thing I didn't call out is that dynamic memory now in 2012 helps an organization actually hot add memory. So whilst we don't call it out as a feature, you can hot add RAM to a running virtual machine. If the VM is enabled for dynamic memory, I can adjust the minimum and maximums on the fly. So if a VM is already at its maximum, you've given it 4 gig as the maximum dynamic memory, and it's there, and it's kind of, I need more RAM, I need more RAM. Well, let's adjust it to 8 on the fly, and then Hyper-V will start to deliver more memory into that virtual machine at that time. So we touched on resource metering. Now, vSphere, if you've used vCenter, the granularity you get within vCenter around some of the metrics around virtual machines and what's going on the host is very, very granular, presented in pretty good graphs, and we get a lot of visibility. If you're just using the vSphere hypervisor on its own, you're not going to get some of that centralized view because you're managing on a host-by-host basis. vCenter and vSphere obviously aggregate a lot of that. We talked a little bit about quality of service, and today in Hyper-V, quality of service is network-based. However, what if you are using network-based storage? So maybe you're using SMB. You're attaching your storage across the network. You could therefore then utilize some of the QoS capability for storage in that respect. And then we finally touched on data center bridging, which is an emerging area we're seeing more and more people think about as a way to carve and slice and dice their network in order to better use the resources they have with the bandwidth they've got available. And DCB utilizes some of the converged networking adapters within servers that can also do things like hardware QoS. So instead of using the software QoS that we provide through the network control that I just talked about, we can do it in hardware working with those particular vendors. So you can be a little bit more granular as well. So that was a little bit about scale, performance, density. And let's change direction. And let's talk about security. Because within Hyper-V, if you think back to 2008 R2, the network switch was very simple. It just got VMs talking out to the LAN, to the other virtual machines, whatever it may be. It was simple, it was effective, but it didn't let people do everything they wanted to do in terms of extensibility. It didn't give all of the granular features people are looking for their network infrastructure. But in 2012, that extensible switch, which is built in every edition of Hyper-V, it's the default switch, it's completely extensible, which means partners, customers can plug in and manage through standard Windows interfaces, But when we look at some of the more advanced capabilities that are now exposed because of this extensible switch, we can see we've got things like PVLANs, so an extra level of granularity within the VLANs. Now, that's not exposed through the GUI in Hyper-V. That's something you would configure through PowerShell. And if you think about where PowerShell is going in 2012, or has gone in 2012, you think back to 2008 R2, there were just a couple of hundred commandlets. There's a couple of thousand commandlets now for Windows Server 2012. So the granularity you can have with PowerShell is phenomenal. And for Hyper-V specifically, a lot of stuff is exposed only through PowerShell. Things like the PVLANs, for instance, is a good example of that. We're helping to provide more granular security capabilities, protecting against rogue DHCP and routers on the network, but also things like protection against ARP and neighbor discovery attacks. So we can ensure that we're looking and tracking that kind of information and ensuring that your virtual machines are as secured as possible. The monitoring and port mirroring. If you want to have a source VM that's siphoning off its traffic to another virtual machine for analysis or sniffing or whatever, in the box. Easy to configure. That's one that is exposed through the GUI. And also, if you've got a requirement for a virtual machine to be almost a central point for lots of VLANs to converge, you can effectively trunk on the virtual NICs now. So I can trunk all different VLANs of which I choose into a single VNIC, which is really helpful. And then finally, when we're starting to control traffic and who can talk to what, some of the port ACLs allow us to be fairly granular around this VM can't send to that VM over this port. And again, that's configured through PowerShell. When we look at the real power of the extensible switch, yes, we do some cool stuff. We've got a couple of key features within the switch itself. But it's extensible, and it's being extended by partners. And in the examples and you can see on the show floor in the expo hall, partners like Cisco really starting to get behind Hyper-V as a platform to deliver capabilities not only integrated with UCS, but also the Nexus 1000V, which is probably one of the most requested extensibility features for the Hyper-V switch. Does it integrate with the Nexus? Has Cisco got a build available? And yes, they do. And you can go and learn more at the Cisco booth that they've got in the expo hall. So they're extending the Hyper-V switch to plug in and help customers really take advantage and plug in with their wider network infrastructure. When you think about Five9 are providing a solution to deliver, number one, a virtual firewall, very granular, easy to deploy, easy to configure, but allows you to define very granular firewall rules between different virtual machines. But the second one they're delivering as part of that security manager is an agentless antivirus. So rather than putting agents inside all of the guests, if you're doing, say, for instance, VDI, maybe you want to look at a solution that doesn't involve agents inside guests. And I think we're still at a stage in the industry where it's not necessarily been hard-baked that, well, agentless is the way to go versus agent-based AV in that environment. There's certain considerations you've got to make around scanning and times that happens, and get a combination with your storage array especially, all these scans taking place at one point. But Security Manager from Five9 is helping organizations who do want to go down that route and have an agentless AV for Hyper-V, they can achieve that. And that would compare and contrast fairly closely with what VMware deliver with their endpoint. That framework they provide within vSphere to allow a third party, an AV vendor, to plug in with a specific piece of functionality. When you think about the OpenFlow switch from NEC, again, another example, slightly different target. Nexus 1000V for those Cisco customers, but for companies who are looking at almost like an open vSwitch type approach, the NEC solution helps them to plug in there. And finally, for more advanced and granular packet sniffing and traffic analysis, InMon with their S-Flow product is providing a lot of capability for those organizations looking to do that. And those extensions are taking place at multiple points in the extensible switch, whether it's for inspecting packets, whether it's for shifting stuff around based on source or destination, whether it's about detecting threats. All of that capability is exposed through the Hyper-V switch. And the beauty of this extensible switch is I can choose one, I can choose multiple extensions and have them running simultaneously. So it's not about saying, okay, let's replace the Hyper-V switch with something, but then I can't use this. It's about saying, okay, if you want to use this in combination with this and this, then you can do that. You plug them in at the relevant point, and it's simple to configure and easy to extend for partners. When we look at what VMware is doing in this space, the vSphere hypervisor doesn't have that granular capability. it's reserved for those higher editions of vSphere, and rightly so. It's a more advanced capability. So we think about what we've got in the switch side. The vSwitch, the regular vSphere vSwitch, the networking switch, if you think about that vSwitch, when you want to apply the IBM equivalent of the Nexus 1000V or the Nexus 1000V itself, they're effectively replacing the vSwitch. So it's a different type of approach. Hyper-V's taken a very extensible base. And there's a number of extensions we've already confirmed from the likes of Cisco and Five9 and the ones we've talked about, and there are more on the way as well. But you'll see many of the capabilities are still delivered by both Hyper-V and vSphere, those more granular networking configurations. But some of the key ones are now reserved in vSphere for that vCloud networking and security suite. So it's an extra set of technology, but provides you with some of the more advanced capabilities. Now, the reason it says partner there on the right-hand side is if you did have the Cisco Nexus 1000V, then you would have many of these and many more capabilities integrated with your vSphere environment. And it's the kind of stuff they're also bringing to the Hyper-V side as well. So it's great from an ecosystem perspective that you're making the most of those investments regardless of your hypervisor platform. Now, when it comes to performance, we talked about scale, performance, density earlier on. We've been really busy on the network side. And you saw it in the keynote, network virtualization, which we'll touch on a bit later. But some of the underlying stuff, just to make things run faster and more performantly. We've done a lot of work in Hyper-V to ensure that's the case. So things like VMQ for processing traffic, offloading to specific network cards within the environment, within your host, can see an increased level of performance because we're processing that traffic more efficiently across more processors in the system. So helping you to process that faster and more efficiently. But if you've got an investment in IPsec, so IP security, which Microsoft has got a huge investment in our environment, if you think about if you did have IPsec enabled, IPsec involves a lot of encryption and decryption of stuff, of traffic. And that usually means that the local machine handling that processing and traffic is going to need a little bit of CPU and memory and activity in order to process and decrypt and encrypt. If you've got multiple servers on a single host that are effectively handling that, that's amplified. It's multiplied by the number of servers you've got on there, all handling this IPsec encryption and decryption. Well, we can offload that to specific network hardware inside the hosts, so NICs that have that capability, and that reduces the burden on the hosts themselves and increases performance. But the final one is SRIOV, and this is where we're seeing customers get even more excited about driving the highest levels of performance. Because it's commodity network adapters that are coming with this kind of functionality now. It's not just the high-end, the 10 gig NICs. It's the 1 gig NICs that come as standard on many industry servers now. I can turn on the SRIOV capability, and it typically needs to be turned on in the BIOS, and you may need a firmware update for the NIC. But once you're there, you can then enable that in Hyper-V easily. And what's going to happen is Hyper-V is going to transplant a virtual function. So these SRIOV NICs, yes, there's one NIC, you can touch it, you can plug a cable in, but in there, that's the physical function. But this NIC has got multiple virtual functions. So when you enable SRIOV for a virtual machine, it takes one of those virtual functions and uses that inside the virtual machine instead of the native Hyper-V vSwitch inside the VM, or the vNIC, sorry. So you're using effectively a virtual representation of the physical NIC inside the VM. So if it was Broadcom, that's what you'd see inside the VM. If it was Intel, that's what you'd see inside the VM, rather than a Hyper-V virtual machine network adapter. Why bother? Why do that? Increase levels of performance. Some of the performance testing we're doing at the moment with a third-party workload on Hyper-V, so not a Microsoft workload, they're seeing massive performance gains for this particular workload for SRIOV, utilizing it. And as we come to market with best practices for this workload, as we go forward in the next couple of months, you'll see that that's a specific piece of guidance. Use SRIOV if you've got it in your network adapters, because it can drive higher levels of performance, lower latency. But what we don't want to do is give with one hand, here's phenomenal performance, near-native network performance, and then say, you know what, you can't move that VM anymore. So SRIOV fully supports live migration. So even though we are binding a virtual representation of that Broadcom NIC in this host, even though we're binding that to a VM running on this host, we can still shift that VM around. We can still live migrate it around the infrastructure. So we're doing some clever stuff about ensuring that, yes, you can take advantage of these high levels of performance, but you can still move stuff around. Now, I don't know how many of you require encryption on your systems from a compliancy perspective, from a location perspective. Maybe something's in a less physically secure location. But a lot of organizations believe, a lot of people believe that BitLocker encryption is just a client thing. It's in Windows Client, it's in Windows 8, it's in Windows 7, it was in Windows Vista. Well, it's on the server side as well. It's a free feature that you can turn on, and yes, there would be a performance hit of a couple of percentage points, but BitLocker now enables me, through its increased flexibility, to encrypt disks that are running in the machine, in the chassis, so local disks, regular LUNs from the SAN, and cluster shared volumes. So all of the key types of LUN, or storage repositories that are presented to Windows Server to store VMs and stuff, can now be BitLockered. Now this is at the host level. I can't do this inside a guest. There's a requirement there that doesn't exist inside the virtual machine hardware. But this is something useful for servers that are going to be run in less physically secure locations, or in environments where there is a requirement for encryption from a compliancy standpoint. So it's helping to ensure that we're delivering that highest level of security. And when we start to do a bit of comparison, VMware offer capabilities to enhance the processing of network traffic using what they call NetQ. But in the Hyper-V side, that equates to VMQ. But don't forget, in 2012, it's dynamic VMQ. So we're taking it a level higher to better utilize all of the processors within that system to optimize the traffic management. The key thing I called out was the SRIOV. We want to make sure that you can have that optimized traffic performance and still shift stuff around. Okay, SRIOV support was introduced in vSphere 5.1. So you can take advantage of it, it just doesn't have that integration with vMotion. Okay, so it's something to be aware of. And the storage encryption, it's a feature that's unique to Hyper-V. I'll be honest, I don't know, I've not met a huge number of people using it in their environment, because many of the servers that are running Hyper-V are locked in the data center with multiple levels of physical security that people have to go through. So it's not like I'm going to walk in with my badge that I made in Paint and show it to the front desk and say, oh, I've come to fix your server, and out the door we walk with it. You know, that's not the likely scenario. But if you've got a compliancy requirement, then it can be very, very useful in meeting that. So, flexibility. Hyper-V in 2008 R2 introduced live migration. It had already been in the VMware portfolio for a significant amount of time at that point. But what we're seeing now is vMotion on the VMware side is starting to drop into some of the lower-end SKUs. So it's becoming more accessible to customers who perhaps would have had to upgrade to the highest SKUs to get hold of it. And Hyper-V introduced live migration in every SKU. So in that free Hyper-V server, I could establish and build a cluster and start to move virtual machines around flexibly. But the challenge was in 2008 R2 is the maximum cluster size was 16 nodes, so 16 physical Hyper-V boxes, and you can only migrate one VM at a time between two hosts. So if you think I've got 16 hosts, one VM at a time between host 1 and 2, host 3 and 4, I could be doing 8 simultaneous migrations at any one time within my network, within my cluster. But that wasn't flexible enough for some people. What if I had a host with 100 VMs and I wanted to put it in maintenance mode and just evacuate? I'll do one at a time, I'll move this VM first and then I'll move it. It wasn't flexible enough. So we listened to customers' feedback and we've improved that solution to enable you to simultaneously live migrate virtual machines across cluster nodes effectively with no restrictions. You can specify a maximum number of migrations in the GUI, and I think it accepts around about 10 digits. So you can put 9999999. You're not going to do that many, and your recommendation is going to be specific to your environment. We could say, you know what, on 1 gigabit Ethernet, don't do more than 4 live migrations at a time. Or on 10 gig, don't do more than 8. But why not? What determines that? We're not going to say you can only do that. It's based on your workloads, okay, whatever you want to do. But we're confident that we're offering great performance for live migration, and we're optimizing the use of the network bandwidth that's available. But as a best practice, you would have a dedicated live migration network in exactly the same way you would in a VMware world. We introduced the live storage migration, so shifting those disks around the infrastructure, moving them to one new location, moving them to different locations. And that's something that ODX, that we referenced earlier, would accelerate. So it would reduce the burden on the host for that migration process, and it would make it considerably faster as well. But we took the best of the live migration, shifting the memory, the running state, and we took the best of storage migration and bundled them together with a catchily named feature known as shared nothing live migration, where literally nothing is shared. All I need to have in place between my hosts is a network cable, which enables me to have complete agility. I want to move a VM from standalone host to cluster node. Off it goes. I'd then like to move from that cluster to that cluster. Off you go. And then I'd like to move from that cluster back to standalone node. I can do it. It's shifting the memory and the disk simultaneously to help you move virtual machines around pretty much wherever you want to go. There is that requirement on the network cable, although we've seen demonstrations of people do it over wireless, so even that isn't even a requirement. It can be done, probably not in a data center environment, though, but for laptop demonstrations, it's fine. This is the key thing here, delivering the level of agility that you want for the environment. Why should you be shackled? Why should I have to keep that VM there and not be able to move it anywhere? We're confident we're delivering the key things that customers need to move workloads around flexibly. And VMware introduced that same kind of capability in vSphere 5.1 as well. So now, both organizations, both vendors have got choices around, do I shift the VM's state, do I move the disk, or do I move both? Interestingly, though, the shared nothing equivalent, enhanced vMotion, if you will, is only triggerable, or you can initiate it from the web console within vSphere 5.1. So it can't be done from vCenter. But then we get onto the network. And the network, and you'll have learned more about this at the conference as well, we've got a phenomenal opportunity to change the way we deliver the network infrastructure. With network virtualization, we're providing the ability for organizations to isolate without VLANs, so I can carve up my network without the need to use VLANs anymore. So I could have a red network and a blue network and a green, whatever I want to call them, but they're isolated using the technology within network virtualization, which we'll explore in a minute. Combining with those flexible migrations, and we saw it in the keynote, being able to move a VM between, in this case, two segments of our infrastructure, two data centers potentially, if you've got the link speed there. And if we acquire a new company or we merge or have a partnership, think about the example in the keynote as well, where we had Fourth Coffee was acquired by Contoso, those usual names. And because we could use network virtualization, we could onboard them very quickly, not have to re-IP address stuff, and make it a very seamless transition, more so than having to integrate lots of VLANs and switches and a lot of configuration that could very easily go wrong and cause outages. So how does it work? What is it all about? Well, if you think about your fabric, your physical fabric, these are our Hyper-V hosts. They're all on a single flat network at this point, 192.168.2.10 through to 14. These IP addresses are what we'll call our provider addresses, our PAs. And these are unique to each Hyper-V host, and they can be found across the physical network. But then when we create our virtual networks on top in Virtual Machine Manager, so that's a key point to note, VMM is your tool to manage network virtualization for Hyper-V. Can you do it without VMM? Yes, but it's tricky with PowerShell. A lot of PowerShell work would be needed. VMM makes it massively simplified. The concept of it is the most tricky part in VMM to get your head around, with logical switches, logical networks, and so on. But once you've grasped that, and there's been some good sessions this week on that, you can then start creating networks just like they're going out of fashion. And the beauty of network virtualization compared to VLANs is it'll support 16 million networks. Some VLANs, some switches are capped at a significantly less number of VLANs, 1,000, maybe even less. We've seen customers now who are reaching that upper limit of their switches, and they're wondering where they go next, because the configuration challenge from them going forward is big. But these VMs in these particular VM networks have their own IP addresses as a guest OS. It's got an IP address that it communicates. That's known as the customer address. So you've got provider address in the physical world. You've got customer address is effectively the guest OS of the virtual machine. And Hyper-V and VMM work together to ensure that they know the relationship between provider and a customer address. So they know where these VMs are residing, and they know the different paths for communication. And VMM maintains that policy table and distributes portions of that table to each of the respective Hyper-V hosts as and when they need it. So each Hyper-V host doesn't have a massive collection of this table. It just has what it needs to function and to provide the right traffic guidance and routing. So when we look at this particular example here with the 2 stars, 2.12 as a host, 2.12 as a host, has got a couple of VMs on there, one blue, although the text is green, one blue and one red that are identical. So there should be a conflict if we weren't using VLANs or network virtualization. But that's the exact point of network virtualization, abstracting that away and simplifying the administration. And how's that achieved? It's achieved through GRE, NVGRE, Network Virtualization Generic Root Encapsulation, which is a mega acronym. But you see here, we've got physical hosts. Yeah, they're on our different subnets. We've got virtual machines on there. These virtual machines have their own vSID. Okay, so that's one of the unique identifiers to identify that virtual machine network. Okay, so we can identify the VM, where it is, which host it is on, and which virtual subnet it's within. And the GRE element of that, when we send a packet from a virtual machine, so from 10 to 11, it's got to go across the physical wire. It's got to get there somehow. And the GRE element of that is it's like putting a letter in an envelope. The GRE is the envelope that we chuck in the mail system. In this case, GRE wrappers the VM packet and sends it across the wire. Okay? But if we look at that in a bit more detail, we want to send traffic. So this is us sending traffic from blue 1 in the top left to blue 2 in the top right. So blue 1 doesn't know where blue 2 is at this point and says, oh, where is it? I'll send out an ARP. I'll send out that broadcast to see. Come on, somebody must be able to tell me what's going on here. So it sends an ARP packet out. The Hyper-V switch broadcasts that to the local virtual subnet ID. So it just checks on that local host, on that local vSID, are you here? Are you right next to me? Is this VM right here or on the same host? If it's not, it then broadcasts the ARP to the rest of the network, or at least it thinks it does. Because the network virtualization filter grabs that ARP and says, whoa, we're not going to push this out onto the network. This is going to cause a lot of excess traffic. So we'll capture it, we'll check our table, and that will tell us, okay, yeah, I know where blue 2 is. It's on that host with that provider address. Here, let me get that information. If it doesn't know, it'll grab it from VMM. So we'll get an updated table if it doesn't have that information. And it's at that point that the network virtualization filter sends that response back up the stack to tell blue 1, yeah, I know where it is. This is where you need to send it to. Blue 1 then constructs its packet to send. It has no idea network virtualization is going on here. It's completely oblivious. So it just constructs its packet. It's been told how to get from A to B. It's put the relevant MAC address together and the relevant IP addresses. Hyper-V switch, when it passes through the switch, Hyper-V attaches the vSID, and then the network virtualization filter checks with those ACLs to see if it can actually contact this particular VM, if it's allowed to. And it's at that point that we construct the GRE packet. So we wrapper that VM packet with the extra information it needs to get from physical host to physical host. And when it gets to the other side, it just happens in the reverse. So it strips off the particular GRE packet because it's made it that far. It's got to this host. We know the VM is above us somewhere. It passes it up the stack, and the Hyper-V vSwitch removes the vSID and passes the final packet through to the virtual machine. And that's network virtualization in action. And in the demo in the keynote, we showed a gateway. Why is the gateway important? Well, the gateway is important because these two hosts in our example here understand network virtualization. They've got the filter. They've got the stack. But if I was sending that to a physical SQL server or a physical Exchange server, it's going to have no idea. It's going to receive this GRE encapsulated packet and just wonder what to do. And that's why we have the gateways. The gateways handle this translation element. They're removing the GRE and passing the regular packet through to the target server. So you'll find more and more partners bringing to market GRE network virtualization gateways for this specific purpose. So when we compare with VMware, we touched on live migration and the specific guidance around how many migrations you can do at one time. 4 on the VMware side on gigabit, 8 on 10 gigabit. You could use those as a guidance for a Microsoft environment as well. There's nothing stopping you. But we don't say it has to be that way. It's based on your specific environment, and your testing and experience will determine that. The vSphere hypervisor, that free hypervisor, remember, has none of these cluster capabilities. You can't enable VMware HA, thus you can't turn on things like vMotion, DRS, and so on. Now, I've included a couple of lines here around automated live migrations. In VMware, an incredibly popular feature, which I'm sure some of you are using, is DRS. Balancing virtual machines around your clusters based on changing conditions. So if you've got a host that's very heavily laden and one that's quite light, DRS will move virtual machines around on the hosts transparently to the VM itself with no downtime. Hyper-V doesn't have that capability on its own. It has the engine to get the VM over from A to B to C to whatever, but it's lacking the guidance, the brain associated with where we should put stuff. And that's where VMM provides that guidance through its dynamic optimization. Now, there was a time when I needed to combine VMM, Ops Manager, say a little magic word, make sure it works, fingers crossed, and then it will start load balancing across the cluster. That's gone away now. All you need for balancing your VMs across your cluster is dynamic optimization. So if you're looking for a comparison apples to apples with DRS, you would need VMM on top of Hyper-V. So you would need System Center. But System Center, as soon as you enable that dynamic optimization, you also have the option to turn on the power optimization as well. So DO is the foundation for moving stuff around. PO, power optimization, will shut hosts down based on, well, you know what? We can run what we've got here on 5 hosts instead of 8, and it will shut them down. But if those VMs suddenly go, whoa, increased traffic, you know, we're suddenly starting to get a bit more pressure, VMM will wake those hosts back up. It provides the admin with a nice calendar type approach as well. So I can say, you know what? I want power optimization to be active. I want it to be active on Saturday and Sunday, and maybe after 9 p.m. during the week. But by 7 in the morning, I want to be full, all my hosts back online. So we give you the granularity to specify the dates, and not times, but dates and times, specifically days of the week and also times of the day, to have this configured and turned on. And between those times, VMM will do the rest for you. Now, one thing that is missing in that Microsoft portfolio, yes, we'll balance based on compute, so CPU, memory, disk. We'll take a look and we'll move virtual machines around there, but we won't do any form of storage DRS. So we're not going to move virtual disks around automatically. That's not a feature of Hyper-V nor VMM. You could do it manually. You could monitor with Ops Manager and concoct some kind of runbook to automate that process, but it's not an in-the-box capability. So if you're looking at that storage DRS, if you're a big user of that, that's not something that's in Microsoft's platform today. And we touched on the different types of live migration as well, with VMware vSphere 5.1 Enterprise Plus giving you many of those capabilities. And when we touch on network virtualization, what we provide with Hyper-V is in the box. Hyper-V and System Center provide you everything you need, bar the gateway, which is coming from partners, and you'll see more and more of those come forward. But with VMware, it's not in vSphere. It's in that vCloud networking and security component or suite that we touched on a little bit earlier. So that would allow you to use VXLAN, which is a different approach to achieve the same goal. So it still gives you the massive number of addresses available and all that good stuff and moves beyond the scale limits of VLANs. They are slightly different approaches. They've got pros and cons. But both of those approaches are solutions you can go beyond the regular restrictions of VLANs today. But it's not in core vSphere. It's in that vCloud networking and security product. What we don't know at this stage, and we haven't seen it delivered, is exactly where Nicira will fit with that. Because Nicira offers an even more granular network virtualization capability on the VMware side than VXLAN. So it'll be interesting to see how that develops going forward. Because if the networking is so fundamental, it's not something you change every week. So a lot of you will have infrastructures that will have been defined for a number of years. So swapping to VXLAN and then swapping to Nicira might not be the way you go ahead. But you know, we'll see that come out as we go forward. So to wrap up, resiliency. Windows Server's got a pretty capable in-the-box backup tool, locally, host by host. So if you do want to back up VMs, if you're a smaller organization or you're working with smaller businesses, and you just want a simple but effective backup tool that's incremental, agentless, to back up VMs on local hosts, then the backup technology within Windows Server is pretty capable. DPM, Data Protection Manager on the Microsoft side, within System Center, provides a more complete backup solution for Hyper-V. But on the VMware side, the new Data Protection, especially the Advanced Edition, actually gives VMware a little bit of an advantage there over the in-box Windows Server backup, because it offers a bit more granularity and it's centrally managed. But we provide an in-box efficient backup technology. But this is where it starts to get really cool. Because with Hyper-V Replica, we're providing in the box, no per VM charge, no per VM restriction, no special licensing, in the box replication, software-based replication, asynchronous, from site to site, simple to configure, extendable through PowerShell, automatable through PowerShell, if that's a word, I may have just made that up. Hyper-V Replica enables me to shift workloads from site to site. So in the event of a disaster, I've lost a site, I can bring them up in a second site. If I haven't lost the site and I just want to do some testing, I can test failover. If I haven't lost the site, but I know something's coming on the way and I think, you know what, I'm going to have to shut things down and shift them out of state, then I can do that as well. So I've got planned, unplanned, and testing capabilities, including fixing up the network for the second site. So here we're on 10.10.10. Whatever, and when we move to the second site, the VM automatically comes up with 192.168. Whatever. So we're able to provide a lot of that capability. And vSphere has an in-box replication capability. We're not talking SRM here. SRM as a brain above this in-box replication is a powerful combination. And you may think, well, Microsoft doesn't have an SRM equivalent, a site recovery manager equivalent. Well, actually, you've got a couple of different routes you could take that. You could go with Hyper-V Replica and wrapper it with PowerShell. That's one. You could go with Hyper-V Replica and wrapper it with Orchestrator. That would be another. That would automate failover of a considerable number of VMs at scale between sites. But we've literally just announced in the last couple of days something called the Windows Azure Recovery Services for Hyper-V. So Windows Azure Hyper-V Recovery Manager. Again, another catchy title, but the key thing here is this is a solution that runs from Azure in Microsoft data centers, looks at your VMM managed clouds, so you're managing your Hyper-V host with VMM, looks at them, knows your different sites, and will orchestrate the failover of clouds from site A to site B. Okay, and you can get on that preview now if you want. It's early days, so we've just literally announced it. But the configuration is simple, it's easy to manage, and it would give you a very low-cost solution combining Hyper-V, System Center, VMM, and Azure to shift between sites in the event of a disaster or a planned failover. So certainly something to be aware of. Oh. Where am I here? There we go. And if you do compare some of the granular bits of the replication, Hyper-V offers a lot of capability for that unplanned, for that testing, for that failback process, automatic re-IP addressing. The vSphere replication that's free in box, without SRM, if you're just using that free vSphere replication, then you're not going to have some of those capabilities. And doesn't give you as granular an RTO either. So 5 minutes down for Hyper-V, 15 minutes. So we're making sure that the data is transferred as quickly as possible and you're not going to lose much in the event of a disaster. We took NIC teaming in the box. So NIC teaming is now in the box with Hyper-V to ensure a more centrally managed and resilient solution without needing the third-party tools and utilities. And when we think about clustering and HA, massive scale for Hyper-V. 64 nodes, scale out, 8,000 VMs, easy to set up, dynamic quorum in 2012, meaning I could lose well over half, if not nearly all of my cluster nodes of a 64-node cluster, and the cluster would keep on going. Because the way we've re-architected the quorum to be dynamic based on the number of nodes we have available at any one point in time. Legacy versions of Windows Server and clustering, if we lost over a certain number of nodes, the cluster would shut down itself, and you'd be in a situation where you'd have no further resiliency at that time. That's gone. Dynamic quorum automatically adjusts based on the number of nodes you've got at that time. Guest clustering, to help you cluster virtual machines, like a SQL always-on cluster is a good example, inside virtual machines on a Hyper-V cluster. If you combine those two, how are you going to get the storage through? How are you going to present shared storage? Well, iSCSI, Virtual Fiber, SMB are all supported. We talked about BitLocker, the storage for encryption, and we're working closer with storage vendors to help us integrate more deeply with their arrays, as we talked about. We ensure that the VMs, the guest OSs, and applications are resilient inside the VMs as well. We'll give you a patch mechanism to ensure your clusters are up to date, similar to vCenter Update Manager. So you've now got an ability to patch all your hosts of that 64-node cluster whilst keeping the VMs always up and online. If VMs you want to fail over in a certain order, you can do that with the priority settings now. And the affinity rules, in combination with VMM, allow me to keep VMs apart or try and keep them on certain hosts as well. So many of the key features you're perhaps used to in vSphere are also included within Hyper-V. So when we compare for the final time, Hyper-V is delivering a lot of capability, the replication, the backups, well beyond that of the free vSphere hypervisor, but on par, if not exceeding, that of vSphere Enterprise Plus. So when you look at the guest OS application monitoring, we can provide monitoring. This is without System Center, by the way. This is in-guest application monitoring that we can see, okay, the SQL service is running. The Exchange service is running. And if it fails inside the VM, we'll try and perform some remediation by maybe shifting that virtual machine around or maybe restarting that service depending on what's going on at that time. And the key thing, if you are starting to build guest clusters, so you do want a SQL cluster on a hypervisor cluster, not necessarily Hyper-V, just a hypervisor generically, then there's some things to be aware of. Because Hyper-V are the only vendor, Microsoft is the only vendor that supports, and I mean supports, that's different from will it work or not. So on the VMware side, this may work, but it's not supported. But we support guest clustering with live migration. So I can move cluster nodes inside guests around my infrastructure and utilize dynamic memory for the best level of density as well. So the key thing here, the key takeaway, is flexibility. You can build the guest clusters on top of the hypervisor clusters in the style and shape that you want. So to wrap up, and I'm happy to take questions at the front. I realize that we're slightly overrunning, so if you do want to get off. We've touched on scale and performance and density. We've talked about multi-tenancy and security with the extensible switch. We talked about the flexibility of moving stuff around the infrastructure and network virtualization. And then we finally wrapped up with some of the HA, the resiliency, the replica stuff. So hopefully that's given you at least an insight into how you can compare the two on paper. We've not touched on everything. There's more things we could have talked about without the time. But you can use this. This information is publicly available, and there's an accompanying white paper as well that you can download and read if you're interested. So with that, thank you very much for your time. If you've got questions, please come up, and have a great rest of MMS.